Okay, I'm going to show you a fairly simple thing in Ecotech, that is how to relate the geometry of your architecture, in this case your home, to the solar geometry, that is the path the sun moves through the sky. To do this, again, I'm showing you my home. Hopefully you will have your home modeled at this point and be able to do the similar exercise. What we're going to do is we're going to pick one room in your home. I've taken my bedroom, which is a south-facing room. That's the window there to the bedroom. Though it's south-facing, it's quite a constrained room. It sits within a little courtyard. That means to the east and the west there are adjacent buildings. They have a massive impact on how often the sun actually shines in our room. So I want to explore that and in a way try and understand when that happens during the year. So there's a couple of ways I can look at that. The most simple way is to actually just get inside the room and see what happens to the sun. So the best way to do that is to use a tool here, which is called a section plane tool. If I click on this button here, it instantly cuts my apartment along an axis. You can pick the axis it cuts on. That red line indicates the cut. I can change that by sliding slider up and down. And I can also change the axis. I go to, say, a y-axis or an x-axis. Let's do an x-axis. It then cuts it again on a different plane, and I can slide where that plane is relative to my space. So I'll go to the, let's say, the z-axis, which is in a way the most appropriate here, and I'll put the slider so I can just see into the top of that room. What I've done, by the way, is I've just put the bedroom on a slightly different layer. That layer, if you go to layers, you'll see is internal walls bedroom. I've done that just so you can see what's going to happen. So I suppose the most simple way to do this, if you want to understand whether sun shines in your room or not, is just to play through the sun on any given day. So at the moment I have it set to March. So if the question were, does the sun shine into my room in March, one could quite simply play through hour by hour and see whether it does. And the answer is yes, it does. And one could change the month from March to February, or from March to even December, and ask the same question: does the sun shine in my room in December? Then the answer would be no, the sun does not shine in my room in December. Why is that? Let's try June. Does the sun shine in my room in June? Again, by simply clicking through the hours, the answer would be yes, but not as much as March. So, at a very simple level, we can understand whether spaces get sunshine or whether they don't by this very simple, if somewhat crude, exercise. Okay, the way we've just done it is a bit laborious and doesn't really allow much of an insight into understanding exactly when the sun shines in and shines out. We have to kind of look at it in a rather crude way. A better way to look at it is to use what's called a sun path diagram. So we can have a look at a sun path diagram by clicking on Calculate Sun Path Diagram. This is what it comes up with. I will explain this in the lecture, so you need to look at the lecture notes again to understand how that works. But actually, it's pretty useless in that empty form because it doesn't really tell us about our architecture. It just tells us about the sun at that latitude. So to make it more useful, what we have to do is select an object and ask what that object sees of the sun with respect to the other objects around it. So there's our window, and we know for a fact that that window is overshadowed by a few things. It's overshadowed by this part of the building here, it's overshadowed by that building there, and it's also, I suppose, to the south, going to be overshadowed by this building here. This is my neighbours. So understanding how all those three elements come together is best done using the sun path diagram. What we do is we need to isolate one element. So we're going to isolate the window. To isolate a window, I select make sure the current zone is glass, which is where my windows are, and I press F4. Pressing F4 will isolate all but those zones, And what I'm going to do, again, not in Visualize, but in 3D Editor, click thing there, I'm going to pick one of those windows, which is this one into my room there. Now by clicking that, and by again pressing F4, which will reactivate all the other layers, I'm then left with potentially a more interesting sun path diagram, which I'll load up again, this time with something selected. I will calculate sun path diagram. And this time, instead of being a white sun path diagram, it's a black and white sun path diagram. The black bits, which are shown here, they represent the obstructing effect of the surrounding buildings. The white bit represents where there's no obstruction. That means where this window can see the sun. So we can understand what the black bits are almost intuitively. We know that the bit behind the line, which is the line of our window, that is my building. That's the building in which I'm sitting. We know that this bit here, that is, from the window's perspective, the obstruction on the left-hand side. And we know that this bit, that is the obstruction on the right-hand side. And we know that this bit of black, he is my neighbour's building opposite. So what does this tell us? Well, it tells us a few things. Again, if we take month by month, I can drag the sun and we just take it to the month of January. Well, I can see that in January, if I follow the path of the sun from when it rises just after 8, and as I bring it across through its day, we can see that the sun is always over a black bit. And that means that basically there's always an obstruction between my window, which is the basis of this sun path diagram, and the sun. Which means that the sun will never shine in my window because there's always something in the way. And then go up to another month, I go to February. Well, in February, again follow the line over, and I realize, well, it's almost the same. The sun will never shine in my window in February because, again, at least at the center of the window, and this is all true for the center of the window, not the very top, the sun will never see the center of the window. But if I look at March, what I find is that the sun rises, and as it comes up through the sky, by the time it gets to just after 11 o'clock, then, in terms of the sun path diagram, it's now over a white part, which means that there's no obstruction between the sun and my window, which means the sun is shining through my window. So I can now say that on March the 1st, the sun shines through my window, the center of my window, between 11 and 12 and 1 and a little after 1 o'clock. It will still be shining in my window. So this becomes a kind of a really useful tool because I can now month by month precisely say when the sun will shine in my window and when it will not shine in my window. Now the sun path diagram isn't the easiest to read for people who are not used to it. So what I very often do is I translate the sun path diagram. Here's a different project, different sun path, different relationship to the sun, but this principle is the same. The dark parts represent an obstruction, the white parts represent a view to the sky. So what I would generally do is I would translate that diagram into this format, which is a little more easy to understand for people generally, which is again to say, look, when does the sun shine on a month by month basis through the window? And this becomes a super useful way to in a way demonstrate a quality of a space which is about its connection over time to the sun. So then looking back to the main model we have, so that methodology can be applied to any windows. If I were again to repeat, press F4 to look at my windows only, and again pick a different window, let's take this one then, which faces west, and then again press F4 to reactivate anything else, press the sun path diagram, I get a different relationship, which is again looking about how this window sees the sun not in the middle of the day but towards the end of the day, and the obstructions around it. And I can apply that to any window I want. F4, let's have a look at this very small window here. F4, turn on everything, calculate sun path diagram. And so it's a very different setting for each window. Let's just take this one again, F4, sun path diagram. What I'll finish by saying to you is that this view can then be exported. If you export it as a meta file, or save it to a PDF. You can then bring this file into Illustrator and begin to play with it. I don't have Illustrator on this computer, but what you guys can do is take it into Illustrator, begin to change the transparencies of each of these shapes, and very quickly what you'll realize is that the view and the black shadow masks that you see here actually have within them a whole lot more geometric data, which is very useful to investigate and to understand.